Hello students, let us discuss about general properties. So in general properties, the first one is atomic and ionic radii. So what here? First one is, in this first one we are going to speak about atomic and ionic radii. So here, what is atomic radius? Atomic radius is nothing but what here? The distance between the nucleus of an atom, we call it as atomic radius. Coming to ionic radius means what? Which will describe about cation and anion charges, we call it as ionic radius. So what is atomic and ionic radius here? Atomic will speak about the distance between the nucleus in an atom, and coming to half of the distance between the nucleus of an atom, we call it as atomic radius. Ionic radius is nothing but what here? Which will determine about cationic charge and anionic charge, we call it as ionic radii. Okay, so here generally atomic and ionic radii of the boron family is smaller than group 1 and group 2. Why? Because these will be having higher value of nuclear charge in boron family. And coming to here, in a group, what will happen means it will increases. Atomic and ionic radii in a group, atomic and ionic radii increases from top to bottom and decreases in a period from left to right. So atomic radii and ionic radii, what happens? Increases from top to bottom in a group and decreases in a period from left to right. Okay, so what is the reason here? Why it is increasing and why it is decreasing? The reason behind is what means, so here nuclear charge is increasing, so whenever you add electrons to the same shell, automatically the size is increasing and nuclear charge is increasing. So there is no screening effect when you add the electrons. So because of the increase in nuclear charge, size is going to decrease. So because of this reason only, it decreases in a period. Coming to group, what happens? The size increases by addition of new shells. So automatically what happens? This one due to the presence of increase in group. So what happens here? In a group, size increases when electrons added to new shells. Okay, so in a period, what happens? In a period, nuclear charge increases and size decreases. So because of this reason, atomic and ionic radii increases and decreases in a period and in a group. So if you have been taken a nucleus, so this is nothing but what? Nucleus. So when you add electrons to the shell like this, so automatically what happening? So here when you are adding electrons like this, automatically here the size is increasing. So when you add addition of new electrons, the addition added to new shells, automatically the electrons is increasing. So automatically what happens? size is increasing, then atomic and ionic radii also increases. But coming to period, what happening, the size is decreasing, the inner side will decrease. If suppose in a classroom I'm taking 100 members of students, so automatically there is a crowding, yes or no? So but coming to here, what happens, whenever the crowding natures, automatically the place will be not sufficient. So whenever you are adding a student to the classroom, the place is not going to sufficient place we are not having. So means what here, the size is decreasing here from left to right, from left to right size is decreasing, from top to bottom what happens, size increases. So and also nuclear charge is increasing. So in a period what happens, it decreases, and coming to here, in a group size is increasing when added to new shell. So this is about atomic and ionic radium. So now let us see next one, ionization energy or ionization enthalpy. What is next property, next one? Ionization energy. So what is ionization energy here? Ionization energy is nothing but here the minimum amount of energy, the minimum amount of energy is required to remove an electron from the outermost neutral gaseous atom is known as what here? Is known as ionization energy. Okay, so what is ionization energy? What I have told you. So here we are taking a neutral gaseous atom. So this is a neutral gaseous atom. It requires some amount of energy, that is ionization energy is required to remove an electron from the outermost neutral gaseous atom. So we are removing electron from the outermost neutral gaseous atom. That one we call it as what here? Ionization energy. Okay, so it requires some amount of energy to remove an electron from the outermost neutral gaseous atom. We call it as ionization energy. So in a group what happens? In a group it decreases. Coming to in a period what happens? It increases. So we are having third ionization energy and also second ionization energy. Okay, so here coming to here, the first ionization energy of these elements means boron, aluminum, gallium, indium, thallium. If you have been taken, so these elements what happens means ionization energy of these elements are very less compared to 2a group elements. Why? Because so p electrons are having very less penetrating power than s electrons. So s electrons are tightly held by the nucleus compared to p electrons. Why? Because p electrons will be having pi bonds, s electrons will be having sigma bonds. So here to remove an electron from the p orbital, less energy is required to remove an electron. So here we are having second and third ionization energy which are higher than the group 2 elements. Okay, so when you remove one electron has stable configuration, so it will be having more penetrating power. It is difficult to remove the second electron. And in the same way here what happens means ionization energy. So we are having what? Second ionization energy and also third ionization energy. Second ionization energy means what? From unipositive ion we are removing an electron. From unipositive ion we are removing an electron. And from here, from dipositive ion, if we remove an electron, That one we call it as third ionization energy. What is second ionization energy? Minimum amount of energy is required to remove an electron from the unipositive ion. That one we call it as second ionization energy. Coming to third ionization energy, what happens? Minimum amount of energy is required to remove an electron from the dipositive ion. We call it as third ionization energy. So here, compared to first ionization energy, second ionization energy and third ionization energy is having more penetrating power. So means what? More penetrating, which we cannot be remove. It's very stable compound. We cannot remove electron easily from the second unipositive ion and first unipositive ion. So coming to here, what happens in a group? In a group, ionization energy decreases from top to bottom. So coming to here, in a period what happens? Ionization energy increases from left to right. So means what is the reason? So what is the reason it is going to increase and it going to decrease here? The reason behind is due to less screening. So because of the removal of one electron, it is difficult to remove the second electron. Okay. So means what this all is explained due to screening effect, we can say. So due to the screening effect. So here this all due to screening effect. So what is screening effect? Screening effect is always inversely proportional to ionization energy, we can say. So what is the reason here? The reason is due to screening effect and addition of effective nuclear charge also, we can say. So here less screening. Due to this, ionization energy increases when size will increase. If suppose this will be having poor shielding effect, we can say. So means what we can say here? What is the screening effect? We can say screening effect is nothing but here you are taking a nucleus. These are the shells. So this is the outermost electron. In inner shells we are having electron. Okay, actually this electron should attract the nucleus, but what happening here? This inner electron reduces the attraction of outermost electron to the nucleus. So means what? This inner electrons, it reduces, means the outermost electron will attract the nucleus by reducing the inner electrons. We call it a screening effect, or we can say shielding effect also. So what happening? The inner electrons is causing screen between the nucleus and outermost electron. We call it as what here? We call it as screening effect. So due to the presence of screening effect, we can say what here? Due to the presence of screening effect, what happening? It is going to decrease the decreases in a group from top to bottom, increases in a group period from left to right in a periodic table. So due to screening effect only this all will happen. So this is about ionization energy. So next we can see about electropositive. What is our next property? Third one is electropositive or metallic character. So what is electropositive here? The electropositive is nothing but here the tendency of an atom to lose electron. Okay, so what is electropositivity? The tendency of an atom to lose electron is called electropositivity or metallic nature, we can say. Okay, so means what here, the electropositivity, it should have metallic character also. So what is electropositivity here? Electropositivity is nothing but which will lose an electron, the atom will lose electron, we call it as electropositive. Here what we are applying, energy is required to remove an electron, but what here happening, itself only losing an electron, we call it as electropositivity or metallic nature, we can say. So generally alkali metals are highly electropositive, we can say. Alkali metals means what here? S block elements, 1A group elements and 2A group elements is having more electropositive when compared to this group. So here the metallic character of the elements increases as we move down the group, we can say. So what happens in a group? What happens in a group? Increases, and in a period what happens? In a period decreases. Why it is going to happen? This is because of increase in size. What is the reason here? Due to increase in size, it increases, electropositivity increases. Whenever the size is increases from top to bottom, automatically it is increasing. Boron is a semi metal, and also here it react more with non metals, we can say. So and also aluminum and other elements are metallic and good conductors of electricity. Okay, so by this what we can say here, it will increases. Why? Because due to the addition of new shells to the size is increasing, automatically it is increases. If suppose a nuclear charge is increases, so means what? Automatically in a period the nuclear charge increases, and here what happens? The metallic character, electropositive character decreases. So what? In a group, due to increase in size of a group, it increases, and coming to in a period decreases due to nuclear charge. Okay, so this is about electropositive or metallic character. So this is nothing but electropositive metallic character. Next one, let us see. Next one is about nature of compounds. What is next property? Nature of compounds. Nature of compounds means what here? Whether it is a gas, whether it is a solid, that one we are going to discuss here. Okay, so coming to here, from the electronic configuration of these metals, it should be having that +3 will be the oxidation step. So boron is having very small and high ionization energy. It cannot lose 3 electrons to form B+3 ion. So means what? It forms covalent compound, we can say. Aluminium also has same tendency to form covalent compound like AlCl3. So whenever the covalent compound is forming like BF3, AlCl3, so they will share 3 electrons with other atoms. So here means what? Here boron, aluminum have only 6 electrons, we can say. Why? Because these compounds have a tendency to accept pair of electrons. Okay, so here they accept a pair of electrons which is known as a Lewis acid. What is nature of compounds? So due to the boron, due to its small size and high ionization energy value, will form covalent compound. Means what here? BF3 it will form. In the similar manner, aluminium also will form the AlCl3. Okay. AlCl3 as a covalent compound it is going to form. So means what? This both is forming covalent compound. So means what? Boron and aluminium share 3 electrons. So by this what we can say? Boron and aluminium will share 3 electrons. So by this what we can say? They have only 6 electrons. By this we can say B plus 3 electrons, losing of electron, gaining of electron. So by this what we can say? Compounds like BF3 and AlCl3 have a tendency to accept pair of electrons is known as what here? Is known as Lewis acid. So this is about nature of compound. Whether it is ionic compound or covalent compound we are going to discuss. So coming to here, boron and aluminium will act as a covalent compound. Covalent is nothing but what here? Shared pair of electrons it is going to have. That one we call it as covalent compound. So next let us discuss about next property, oxidation state. So what is next property? Oxidation state. So as we have seen the outermost electron we are having electron valency how much we are having? Plus 3. So boron family will exhibit plus 3 as common oxidation state for all the elements. Okay, so all elements generally it will exhibit plus 3 oxidation state in their compounds. So here stability of plus 3 oxidation state decreases down the group due to inert pair effect. Why it is decreasing? Why? Because inert pair effect is nothing but what? Reluctance of the ns orbital. So means what? Whenever it will be losing the electrons, so means what here? A pair of s electrons which does not, what is what I have told you here? Stability of plus 3 oxidation state decreases due to inert pair effect. Inert pair effect in a group. In a group what happening? The oxidation state is decreasing. Why it is decreasing? Why it is decreasing means, let us see first of all what is inert pair effect definition. So inert pair effect definition is nothing but here if you are taking s electrons means what? A pair of s electrons which does not take part in bonding, we call it as inert pair effect. So what is inert pair effect? So the pair of s electrons, whenever you are taking s electrons, it does not take part in bonding. So the reluctance of n or s orbitals, or we can say a pair of s electrons which does not take part in bonding, we call it as inert pair effect. So now let us see reason why it is going to decreases in a group. So means what happening here? Why it is decreasing? The reason is nothing but what here? What is the reason in oxidation state? So due to high ionization energy, and also we can say here it will form only covalent bond. So here aluminum compounds are covalent, but they will form hydroxy compounds which will be in aqueous solution. Okay, so if you take gallium, indium, thallium, they will exhibit +3 as well as +1 oxidation state. So means what, as a group it is increasing. Why? Because here ns2 electrons will take part in bonding decreases. So because of this they are having +3 and also +1 oxidation state. If you do 8 minus 5, what you are getting? +3 oxidation state. Yes or no? So what is the reason? Due to high ionization energy of boron, the B+3 will form only covalent compound. And coming to aluminum, what will happen? Aluminum compounds will form compounds are covalent in anhydrous form. So means what, here in aqueous solution it will form Al+3 ion. Why? Because here hydration energy is required. So means what, if you take AlCl3 plus 6H2O molecule, so it will form automatically AlH2O 6 3 plus 3Cl minus some energy is releasing. So this is, and also if you take with indium, okay, gallium, indium, thallium, so we'll exhibit what here? We'll exhibit +3 and +1 oxidation states. So why these are exhibiting +1 oxidation state? It increases. So they will be having s2 electrons, means s electrons is taking part in the bonding. So whenever the s electrons taking part in the bonding, automatically it is going to exhibit +1. Then it increases down in the group. So this is the reason of the oxidation state, why it is decreasing in boron and aluminum, why it is increasing in gallium, indium and thallium. So next property, let us see density. What is next property? Next property is about density. So what is density here? We are going to speak about this speed, yes or no? Volume. So automatically what happens here? The element, so it will be having higher densities. So density gradually what happens? In a group, density increases from top to bottom, and in a period what happens? It decreases. Why these are increasing? Due to the small atomic and ionic radii values, it density will increase in a group, and also the atomic weight of the element will also increase and atomic size also increase. So what is the reason? Due to small atomic and ionic radii, due to small atomic and ionic radii and increase in size, increases in atomic size and also increases in atomic weight, the density increases. So what is the reason? Atomic and ionic radii values will be small, and coming to the size increases and atomic weight also increasing. So because of this reason the density is increasing. So this is about density. So let us see next property. What is next property? Melting point, boiling point and heat of sublimation. What is next property? Melting point, boiling point and heat of sublimation. Okay, so here what happens? Heat of sublimation. Sublimation is nothing but what here? The sublimation is nothing but when solid changes to vapor, we call it as sublimation. So here we are going to speak melting point, boiling point and heat of sublimation. So automatically the boiling point and the heat of sublimation decreases from boron to thallium. It is due to the basis of decreasing interatomic forces as we move down the group. And melting point also decreases from boron to gallium and increases from gallium to thallium. Why? Because on the basis of structural changes we can say. So what we can say here, the boiling point, heat of sublimation decreases from boron to thallium. Why? Why it is decreasing? Due to decrease in interatomic attractive forces we can say. Coming to here, what happens? The melting point decreases from boron to gallium and increases from gallium to thallium. Why it is increasing? Why it is decreasing? Due to here structural changes. Okay, so what happens here? The boiling point and heat of sublimation decreases. So why it is decreasing? Due to the interatomic attractive forces. What is interatomic attractive forces? Interatomic means two atoms. If you are taking two different atoms, we call it as interatomic. Okay, intra is different, inter is different. So when you take two different atoms, automatically what happens? The forces is going to decrease. What are the force is coming? The attraction. If I'm taking B plus and Al plus, automatically the attraction will be decreasing. So because of this reason only it is decreasing. Why it is decreasing and why it is increasing? Because of the structural changes. When the force decreases, automatically the structure is increasing. So because of this reason these are increasing and decreasing. So these are general physical properties. In the next class we can discuss about the chemical properties. Thank you.